Copyright disclaimer under Section 107 of the Copyright Act of 1976. Allowance is made for fair use for purposes such as criticism, comment, news reporting, scholarship, and research. Fair use is a use permitted by copyright statute that might otherwise be infringing. Non-profit, educational, or personal use tips the balance in favor of fair use. Methane and other hydrocarbons. These findings reinforced expectations that Titan's surface could contain lakes or seas of liquid hydrocarbons beneath its opaque atmosphere, a tempting possibility that would drive future research and ideas. The contacts with Saturn and Titan resulted in several scientific findings, opening up new areas of investigation. From the complicated dynamics of Saturn's rings to the ferocious winds and auroras in its atmosphere, each discovery enriched our comprehension of this distant gas giant and its intriguing moons. The mission's findings not only changed our understanding of Saturn's position in the solar system, but also demonstrated the limitless potential of space research to uncover the mysteries of the universe. Crossing boundaries. On the 14th of February 1990, Voyager 1 achieved a milestone that will forever alter our understanding of the universe. It captured the first family portrait of our solar system from a perspective beyond its outermost planets. This iconic image, known as the pale blue dot, depicts Earth as a tiny speck in the vastness of space, a poignant reminder of our insignificance in the universe. Shortly after this historic photo, Voyager 1's cameras were turned off to save energy and prioritize the operation of other scientific instruments on board. This was the ultimate decision. The spacecraft's picture software had been deleted, making reactivating the cameras impossible. Furthermore, the Earth-side equipment required to interpret the images had grown obsolete, cementing this image as a permanent record of Voyager's journey. On 17 February 1990, Voyager 1 overtook Pioneer 10 as the furthest distant human-made object from Earth. It had traveled an incredible distance of 69 astronomical units from the Sun. It travels at an astonishing 17 kilometers per second and has the fastest heliocentric recession velocity of any spacecraft launched from the Earth. Even when it approached the outer reaches of our solar system, Voyager 1 kept a constant eye on its surroundings. The spacecraft's array of equipment, precisely engineered for long-term functioning in the harsh environment of space, continued to relay critical data regarding the Sun's furthest reaches of impact. NASA's Jet Propulsion Laboratory used Voyager 1's plasma wave experiments to investigate the heliopause, which is where the solar wind transitions into the interstellar medium. This barrier is critical to understanding how the Sun interacts with the cosmic environment beyond its direct effect. By 2013, Voyager 1 had reached a relative velocity of around 60,000 kilometers per hour with regard to the Sun. This resulted in an annual traversal of around 523 million kilometers, or roughly 1 light-year every 18,000 years. These data highlight Voyager 1's status as a pioneering ambassador of humanity, racing through space at inconceivable speeds. The argument concerning Voyager 1's transit across our solar system's outer boundaries heated up among scientists, particularly those at the Johns Hopkins University Applied Physics Laboratory. According to their findings, Voyager 1 allegedly hit the termination shock in February 2003, a crucial limit at which the solar wind reduces to speeds less than sound. This milestone, if confirmed, would be a watershed moment in Voyager's investigation, indicating its entry into a zone where the dynamics of the Sun's impact alter substantially. However, this assumption was questioned. Other scientists, as reported in the November 2003 issue of the magazine Nature, questioned Voyager 1's alleged passage of the termination shock. Their mistrust originated from a lack of direct observational data from Voyager 1's solar wind detector, which stopped working in 1990. Without this critical equipment, detecting the termination shock necessitated making assumptions from other onboard data, which was loaded with uncertainties and interpretive issues. The argument lasted until more data could be gathered, extending the scientific debate and the search for definitive confirmation of Voyager 1's crossings of solar system borders. This unresolved nature highlighted the problems of space exploration and the reliance on sensors that frequently outlast their intended operating lifetimes. NASA published a press release in May 2005 saying that there was a provisional consensus among scientists. According to this remark, Voyager 1 is thought to have entered a zone known as the heliosheath. Sheath. This announcement came after a significant scientific session at the American Geophysical Union meeting in New Orleans on 25 May 2005, during which Ed Stone, a prominent figure in Voyager mission research, presented compelling evidence supporting the idea that Voyager 1 had crossed the termination shock in late 2004. Heliosheath. In March 2006, a unique event in amateur radio astronomy enthralled both enthusiasts and professionals, demonstrating humanity's persistent passion for deep space exploration. Members of the 1's in Germany completed an unprecedented feat by successfully tracking and receiving radio signals from the Voyager 1 spacecraft using a 20-meter dish antenna near Bochum. This astounding achievement was the first time amateur astronomers directly intercepted signals from the renowned spacecraft, demonstrating both their technological expertise and the collaborative spirit widespread in the global amateur radio community. The significance of this performance was widely recognized in scientific circles. By cross-referencing the intercepted data with the precise records held by the Deep Space Network Station in Madrid, Spain, the amateur astronomers' findings were validated as legitimate and accurate. This validation not only highlighted the outstanding capabilities of amateur radio operators, but also gave crucial information about Voyager 1's ongoing expedition beyond our solar system. On 13 December 2010, Voyager 1 achieved another watershed moment in its journey. It was established that the spacecraft had passed beyond the heliosphere's radial outward flow of solar wind, thus entering a new area where the sun's impact was decreasing. This discovery was made possible by data received from Voyager 1's low-energy charged particle instrument, which revealed a significant shift in solar wind behavior at the spacecraft's location, roughly 116 astronomical units away from the sun. This distance, approximately 18 billion kilometers, marked Voyager 1's entry into interstellar space, where the interstellar wind began to dominate the solar wind. The absence of observable solar wind since June 2010, a substantial departure from prior observations, showed that Voyager 1 had entered interstellar space. This observation was consistent with theoretical expectations concerning the outer edges of the heliosphere, where the solar wind is deflected sideways by the interstellar wind and no longer impacts the spacecraft directly. In March 2011, Voyager 1 carried out a strategic maneuver to further examine its new surroundings. This maneuver, a substantial departure from its planned path since acquiring the iconic family portrait of the solar system in 1990, involves a purposeful reorientation to measure the lateral velocity of the solar wind. The spacecraft executed a precise 70-degree counterclockwise roll relative to Earth, demonstrating operational flexibility and adaptability to changing mission objectives. Despite the reorientation, Voyager 1 remained aligned with its guiding star, Alpha Centauri, and continued to send important data back to Earth. Throughout these movements, Voyager 1's astronomical coordinates kept it in the constellation Ophiuchus, emphasizing its solitary journey through the cosmos as seen from our planet. On the 1st of December 2011, Voyager 1 made another remarkable discovery when it detected Lyman alpha radiation from the Milky Way galaxy. Previously observed in distant galaxies, this radiation had gone undetected within our galaxy due to interference from the sun. The effective discovery of this radiation was a big step forward in astrophysics study, providing fresh insights into the cosmic environment around our solar system. Shortly after, in December 2011, NASA released another significant discovery. Voyager 1 had entered a zone known as cosmic purgatory. In this stationary zone, charged particles from the sun slowed and changed direction, while the solar system's magnetic field strengthened owing to interstellar pressure. This phenomenon resulted in a nearly 50% reduction in energetic particles originating within the solar system, as well as a dramatic 100-fold rise in high-energy electrons from beyond our solar system. Forgotten signals from the stars. On an August night in 1977, the Ohio State University Radio Observatory, sometimes known as Big Ear, received an incredible signal while scanning the skies for extraterrestrial broadcasts. This signal, 30 times louder than the ambient noise in space, lasted 72 seconds and has not been detected since. Jerry Amon, an observatory volunteer, detected the signal while examining data from the previous 3 days. The signal's remarkable features, as well as the sequence of letters and numbers showing its strength, inspired Amon to write, "Wow," next to the printout, giving the signal its well-known moniker. The signal's frequency, which nearly matches the electromagnetic wavelength of hydrogen, a universal element, led the SETI team to the conclusion that this frequency would be ideal for interplanetary communication. The WOW signal's form, which depicted how it appeared when plotted against time, was equally notable. It began with a 6 on the telescope's loudness scale, peaked at U, and then gradually sank back down. This symmetrical pyramid structure has a restricted bandwidth, implying that it was formed by an artificial transmitter, perhaps from an intelligent extraterrestrial source. The signal's origin remains unknown. Some speculate that it could have been a reflection of a terrestrial radio signal bouncing off space debris, or a communication from a hidden military satellite. Others believe it was a fault in the Big Ear's computer system. Despite several explanations, experts are mystified by the signal's short lifespan and inability to be reproduced. The WOW signal is still one of the most persuasive pieces of evidence in the